Hey everybody, welcome back. This is part 2 of the 1.1 solving equation notes for Algebra 2. We're going to continue with example number 4. So if you take a look at this equation, we have a variable only on one side, and when you look at that, both sides of the equations, neither side can be simplified. So we're going to go ahead and just jump into isolating the variable, try to get that x by itself. First thing we're going to do is add 11 to both sides of the equation, all right, which is going to cancel the 11 out there, leaving us with 5/4 x on the left-hand side equals 20 on the right-hand side. At this point, we have a couple options on how we get rid of the 5/4. We can do it in 2 steps, but I'll also end up showing you guys how to do it in 1 step as well. So one method is to start by getting rid of the denominator, the 4. Since that's division, we're going to get rid of it multiplying both sides by 4. Those 4's are going to cancel, and we're going to be left with 5x equals 20 times 4, so 80. And then at that point, we can get rid of the 5 by doing the opposite of multiplying, which is dividing. So we're going to divide both sides of the equation by 5. Those cancel. And we are left with x on the left-hand side equals 80 divided by 5 is 16, and that is the final answer. So that's one approach. An alternative approach that I prefer is when you get to the point where we have 5/4 x equals 20. We can actually finish the problem in 1 step from here. So when you're multiplying a variable by a fraction, you can undo or do the inverse, which is multiplying by the reciprocal. So the reciprocal of 5/4 is 4/5. So we're simply going to multiply both sides by 4/5, because on the left-hand side, the 4's and the 5's cancel, and that leaves us with x equals. And then on the right-hand side, essentially what's happening is you're multiplying by the top number and dividing by the bottom number. So 5 does evenly go into 20. So I'm going to go ahead and simplify that. 5 goes into itself 1 time, 5 goes into 20 4 times, and then it's simply 4 times 4, which is 16. So you can pick which method you prefer. Again, I like the method on the right because it's 1 step versus 2. All right, let's take a look at another example. So now if we take a look at number 5. So in a question like 5, we have a fraction involved here, but it's a little different than the previous fraction. We have 7x plus 1 over 3 minus 5. In this situation, I'm going to work to get that by itself first. So the expression or the term containing the variable, we're going to isolate that. So we're going to add 5 to both sides. So what that's going to leave us with is we're going to have 7x plus 1 over 3, 5's cancel, equals 11. Now we want to get rid of that 3 in the denominator. So we're going to multiply both sides by 3. Again, those cancel. We have 7x plus 1 equals 33. And then it looks very similar to the other question. We need to isolate that x. So for us to do that, we are going to subtract 1 from both sides. Those cancel. We have 7x equals 32. And our final step in order to isolate x is going to be to divide both sides of the equation by 7. Those cancel. So x is equal to 32 over 7. As fractions, we want to see if we can reduce. In this case, we cannot. So we're going to go ahead and leave our answer as 32 over 7, or 32/7. All right, guys, for now, we are going to skip number 6, and then let's take a look at 7 and 8. So 7 and 8 have directions that read a little different. They say solve for y. Basically, what that means is we need to get y by itself. So we need to isolate the y. So we're going to start by isolating that entire expression, meaning we're going to take and subtract negative 3x from both sides. They're going to cancel from the left, and on the right side we're going to be left with negative 5y. A lot of times people forget the negative. If there's a minus in front, it's got to come down. Now, on the right hand side we're subtracting 3x, but negative 15 and 3x are not like terms, so I'm going to go ahead and rewrite this as negative 3x minus 15. At that point, we want to get the y by itself, so we're going to go ahead and divide everything by negative 5. So there's going to be a couple different ways you might see this answer. So in this case, I've got y by itself. Now, every term up top is negative, and I'm dividing by a negative. So in theory, that means all the signs are going to change. So I really can rewrite this as 3x plus 15 over 5. And that is an acceptable answer. An alternative answer would be putting it into slope-intercept form, where the 3x is being divided by 5, leaving you 3/5 x, and the 15 is being divided by 5, which simplifies to 3. So that would be an alternative way to write the answer to that question. Okay, for these notes, guys, I'm going to skip 8. That might be something that we go over in class, but let's take a look at 9. So with number 9, we're still trying to do the same thing. We're trying to isolate the variable and find all the solutions that make the equation true. Both sides of the equation are simplified, so our goal is to get the variable, which in this case is the b, by itself. We need to start by getting b squared by itself. So in order to do that, we're going to divide both sides by negative 5. That's going to leave us with b squared equal to negative 20 divided by negative 5 is positive 4. Now we have to get the b by itself. So right now you are squaring the b. The inverse operation of squaring is square rooting, so we're going to square root both sides. With the left hand side, that's going to leave us with b, and then on the right hand side, square root of 4, most people are going to just say 2, which that is correct. The square root of 4 is in fact 2. But whenever we solve an equation by square rooting, we have to include plus. Sorry guys, the screen is jumping around on me here a little bit. We have to include plus and minus, because the goal is to find every equation or every solution that's the equation true. And if I were to square negative 2, negative 2 times negative 2 is also a positive 4. So we have to include both answers. All right, guys, thank you. Again, I hope you got something out of the video. If you need to, you can always go back and rewatch it, pause it, rewind it, and definitely don't be afraid to ask your teacher for help. That's why we're here. All right, guys, have a good day.